So I want to do a little bit talking about this concept known as short circuiting. And this comes up, this is a concept that comes up when you're talking about logical operators. And specifically when you're talking about and or. So if you remember, we indicate and with the single ampersand, and we indicate or with the vertical line. There are these things called short circuits, which if I do a double and or a double or, and so these indicate the short circuit versions of these particular operations. Now, what does that mean? Well, let's take something into account here. Let's say if we have vector A and it's 1, 2, 3, and vector B 4, 5, 6, 7. Okay, and then we want to do something like this. C is equal to, let me do big brackets here, A sub 1 equal to B sub 1 and A sub 3 equal to, oh, let me not do that. No, let's say A sub 4 equal to B sub 4. Okay. Now, this thing goes in and tries to process this. And so the first thing it says is, well, A sub 1 is equal to 1. Does that equal B sub 1, which is equal to 4? Well, the answer there is no, it does not. So that value is false. And then it comes over here and says A sub 4, but wait a minute, there is no A sub 4. So this thing is going to, this whole thing stops running and gives you an error. Okay. If you short-circuited that, let's do the same thing. But instead of the single ampersand, use the double, which is the short circuit version. Then it comes in and it says, is 1 equal to 4? And that's false. By putting the short circuit there, what it says is, well, this is an and statement. And the way an and statement works, remembering the truth table, and I'll write it again over here. False, false equals false. False, true equals false. True, false equals false. And true, true equals true. Well, what short circuit is saying, well, the first element in this and statement is false. Well, if the first element is false, then it doesn't matter. You don't have to do anything else. By having that one false, game over. And so this would actually not even run this part here, which means you would never encounter the error, and D actually winds up being false. So if you look at it up here, you're going to get an error because both of these terms are going to be evaluated. Down here, the short circuit version with the double ampersand says, well, once I get a false, stop execution because I know the answer is false. Okay? So that's the concept behind short circuit. I can take it a little further, and let's say if I had E equals, instead of it's A1 less than B1, ampersand, and then I'll do A4 equal to B4. Okay? Now, this is going to come in, and this is 1 less than 4, or A1 less than B1. Well, yes, that's true. So then it's going to, since this is true, the AND statement can't short circuit because it's got to look for false. Because of the truth table, in order for this whole thing to be true, all of them have to be true. So I can't short circuit on the value of true with an AND statement. So that means that this is going to evaluate, and this would actually give me an error because I don't know. I need to evaluate that this second statement, because in order for an AND statement to be true, everything has to be true. In contrast, back to the short circuit case in D, once you get a false, you're done. With an AND statement, once you get a false, it doesn't matter what anything else is, you're going to get a false for the answer. So you're allowed to short circuit here. So this is actually the short circuiting case. This is not, and you're going to wind up getting an error for this one, because since this first one's true, it's going to step on and try to evaluate the second one, which actually generates the error. Okay. Likewise, the same thing can happen with an OR, but instead of when you get a false, you stop execution. With an OR statement, it happens when you get a true. So let's say if I said, my marker's going dead. Let's say if I said C equals A1 equals 1, or, and then I say A4 is greater than 3. Okay. If I do that, then this is going to go, and this part here is A1 equal to 1. Well, that's true. Or is A4, well, then this is going to give an error, right? Because this is not the short-circuited version. The second term is going to evaluate regardless. So this whole thing is going to give an error. Whereas if I came in here, I said it's D for D, or now this is going to evaluate to true with a short circuit. That's the double. So this will evaluate to true, and because this is short circuited with an OR statement, remembering the truth table for an OR statement, I guess I'll put that down here, A, B, A, or B, 0, 0 is false, it's true, it's true, it's true. So remembering that, once I get a true, the statement's true regardless. So I don't need to evaluate this, so the error will never happen. Okay. Likewise, if this first statement was false, marker is 9. If A4 is greater than 3, then because my first statement here is false, because that's false, now it can't short circuit on a false because it needs to continue to evaluate till it finds a true. So this is the only case that's actually going to work, because this has got to continue evaluating, and then I'm going to get an error here because there is no A4. And so that's a brief overview, at least an introduction to the concept of short circuiting. And that's why you have these double ampersands and double or statements that give you control as a programmer when you want to use this short circuiting or not.